For this last video, we're going to look at formulas for special series. And so these have a certain pattern that we can automatically go to instead of doing the whole summation. So the first is the sum of n terms of 1. And we find that the sum is just going to equal to your upper limit. So it's just equal to n. And we saw that up here when we took the sum of 1 34 times, it's just equal to 34. The sum of the first n positive integers is going to be n times n plus 1 over 2. And then the sum of squares of the first n positive integers is going to be n times n plus 1 times 2n plus 1 over 6. So let's go ahead and look at some examples. This first one, I have the sum of k equals 1 to 28 of 1. So I have the sum of n terms of 1, and I know that this is just going to equal to n. Well, my n here is 28, so that means that this is equal to 28. The next one, I have the sum of n equals 1 to n of n, and so that follows this second formula here. And that tells me that I equals 1 to n of I is equal to n times n plus 1 over 2. Well, here my n is equal to 9. That's my upper limit is equal to 9. So I'm going to plug in 9 where I see n. So I have 9 times 9 plus 1 divided by 2. 9 plus 1 is 10. 9 times 10 is 90. Divided by 2, and so this is equal to 45. My last one, I have the sum of k equals 1 to 15 of k squared. And so this is the sum of squares of the first n positive integers. And so that's going to be this last formula, which tells me this is equal to n times n plus 1 times 2n plus 1 over 6. Well, my n here is equal to 15, so I'm going to plug in 15 everywhere I see n. So I have 15 times 15 plus 1 times 2 times 15 plus 1 over 6. So this is 15 times 16. 2 times 15 is 30, plus 1 is 31, divided by 6. 15 times 16 times 31 is equal to 7440. And then when I divide that by 6, I get 1240.